All right, peeps. So let's talk about the warm-up a little bit. First problem on the warm-up was a order of operations problem. I wanted to cover this because last week when we had the test, some people were totally lost in order of operations. Order of operations, my understanding, is a 5th grade thing. Here's how I write it. What does the P represent? Parentheses. How do we know it's parentheses according to the rules of PIMDAS? Yeah. It doesn't just mean you have these.
Brackets and
Yes.
square root.
No. There has to be math going on inside the parentheses. In other words, when you see parentheses, it has to be like that. It can't just be a number. Because a number inside parentheses, Andrew, means what?
Means it's multiplication.
It's multiplication, so it falls all the way down the list. So in order to qualify as parentheses for PIMDAS purposes, it has to be math. E stands for?
Exponents.
Exponents. And we know the exponents because they're those little numbers, like this. Okay? Then we have multiplication and division, which are even. So it's basically whichever one comes first, reading left to right in the expression of the equation. Then addition and subtraction, which are also even, left to right. Okay? So when we're evaluating an expression, we need to first determine what comes first. Well, I do not see any parentheses according to the rules of PIMDAS, because there's parentheses, but those don't count because it's just a single number. There's no math. So I go to exponents. I have exponents right here. So this becomes 12 minus 2 times 3 plus, what's 2 to the third power?
8.
Very good, Cameron. It's 8. 2 times 2 is 4 times 2 is 8. It's 2 times 2 times 2 minus 3 times 2. No more exponents. What's next? Multiplication or division. So I need to just read until I find it. I have multiplication here. So it becomes 12 minus 6 plus 8 minus 3 times 2. I still have more multiplication here. So it's 12 minus 6 plus 8 minus 6. Yes, ma'am.
How do you know, like, because I know sometimes the exponent where you, like, 2 times 3, like, how can you tell?
No, well, that's the thing. If you think about exponents, what's the wrong answer for that?
6.
You have to know in your head what you're likely to do wrong. That'll help you prevent yourself from doing it. You just have to know that's the wrong answer. Once you recognize 6 is the wrong answer, you'll take your time a little bit more and think, okay, wait a minute, it's an exponent, so it's really 3 times 3, and 3 times 3 is 9. Okay? What's next in this addition or subtraction?
The first one that subtraction.
Very good. The first one that comes, which is this guy. 12 minus 6 is 6 plus 8 minus 6. 6 plus 8 is 14 minus 6. The answer is 8. The answer is 8. And if you didn't get it correct, that's fine, but please know why. Most of it has to do with you trying to do too many mathematical processes at the same time when you should be going step by step down through the process. And by the way, a way that they love doing this on a test is they'll give you this original problem, and they'll say, according to step-by-step rules for the order of operations, which of the following would represent the third step? Which of the following would represent the third step? And this would essentially be your answer choice. That's a great way to test it to make sure you're going one thing at a time. Okay? So please make sure you're careful about that. The next one, what is the definition of an irrational number? What is the definition? Who's got a good definition for an irrational number? Christopher?
A never-ending number without a repeat.
Perfect. A never-ending decimal that never repeats itself. That's exactly an irrational number. And we have 2 famous examples of an irrational number. Gavin, focus. Claire, give me one. Pi is our most famous example of an irrational number. What did we learn or the other ones, Cameron?
Square roots between.
Perfect. The in-between square roots, what we also call our bad square roots. Our bad square roots are irrational numbers. And finally, on number 3, it says, what is 2/3 of, bless you, 72? That's high? So set it up. Tell me how to set it up.
2/3 times 72 over 1.
Right. And what's the first thing we look for? Cross simplification opportunities. Does 3 go into 72?
Yes.
How do you know?
Because
Yeah, 9. 7 plus 2 is 9. So this becomes 1. This becomes 24. 24 times 2 is 48. 48. Devin?
I did it a different way, but still got it right.
Okay, did you do 72 times 2 divided by 3?
No.
What'd you do?
I just divided 72 by 3.
And then did times 2?
24, and then I just
Perfect.
did 24 2 times.
Perfect.
I just did it.
No worries at all. Bennett?
I already just knew in my head.
Okay.
You know, you mesmerized.
Okay. Not memory.
I already know that.
Okay. Whatever you say there, Benny. Alrighty. Today, listen up. Today we're going to talk about addition of integers. Today we're going to get to addition of integers, then we're going to get to subtraction of integers tomorrow, multiplying, dividing, then mixed practice at the end of the week. You need to please make certain that you completely understand what we're doing, because the first thing you're going to do when you walk in on Monday is take a quiz. Okay? Over everything we're doing this week, so make certain you get it. Now, before we even get started, refresh my memory as to what an integer is. What is an integer, Jackson?
A whole number? A negative number? 0 and yeah, negative number, whole numbers, and 0. Natural numbers.
You're right there. Sierra. Whole numbers and their opposites. All the whole number groups, the entire whole number group, and their opposites.
What about 0?
Yeah, because 0 is a whole number. Okay? All the whole numbers and their opposites. What do we not have? Some of you are asking about the worksheet you did on Friday. The very last question says, was all negatives are integers. Why is that not true, Jackson?
Because some of them have decimals.
Because some of the negative numbers have decimals and fractions.
No.
Okay? You really have to. Some of you didn't do as well on that worksheet as you probably should have. You need to slow down and think. Okay? So here's what's going to happen. When you get back, the dry erase boards that you have, Andrew, what does it say to do on the board with that very thing?
Set it aside.
Andrew, today. Good, so let's do that. Okay? Now, when you get back from lunch, we're going to use the dry erase boards. There are a few ways to understand and to practice how to add integers. Tomorrow is really where the wheels can potentially come off the bus if we're not careful. So today we're going to talk about adding integers, positive and negative whole numbers, basically. And then tomorrow we're going to talk about subtracting positive and negative whole numbers.
How would you do that if it was
Talking about subtraction?
like no, yeah.
Well, that will be tomorrow, so we'll find out then.
Then how would you?
Well, you'll find out after lunch.
Oh, I know.
Okay?
I know.
I'm glad, but you'll still find out after lunch. Okay?
Sure did.
So, I want to talk, adding integers, most kids get. So we're going to talk about it, and there are a few different ways that I can kind of model for you how to add integers. You may use whichever method you are comfortable with. I'm going to give you basically 3 different ways that students kind of wrap their head around how we're dealing with adding together positive numbers and negative numbers. Like I said, tomorrow it gets a little bit weirder, but most kids do it okay. So let's just deal with the adding today. You'll also, by the way, I don't know if you noticed, but on the schedule, I started adding the U2D2, U2D3, those notations, because that's how they are noted online when you look up the documents. So if, for example, you know that if you miss tomorrow, if you wake up, you're sick, your mom keeps you home. Cameron, sit down, please. If you wake up, your mom keeps you home sick, then when you come back on Wednesday, you can look there and you know, okay, I need to go online and look up Unit 2, Day 3, U2D3. Gavin?
Do you have any copies of the test we did on Thursday?
Yes. Yeah, and I'll show you how to request them. So those little green slips in the front pockets, you'll request them using those. I'll show you at the end of class. You'll also notice that I've started adding these things. So I've had some parents who are saying, we don't really know when they have homework and when they don't have homework. Okay? So you should know, based off the day, whether you have homework or not. If your parent emails me and says they have homework, I'm going to say ask them, because they should have looked at the board and known. Okay? Y'all need to make sure y'all are telling your parents when you have homework and when you don't have homework. Remember, you may not turn in homework early. If I give you homework, which we are going to have today, then that homework will go home with you tonight and be turned in tomorrow, even if you finish it in class. Okay? Do what?
If you turn it in early, there's no point in calling it homework.
Well, if you turn it in early, I will throw it away, so it won't be anything really. Okay? I'm way too good looking and important to be bothered with grading things early. Way too good looking and important. So do not bother me with that kind of nonsense. When we are adding, if you think about addition on a number line, if you think about addition on a number line, if I say what is 3 plus 4, right? What is 3 plus 4? When you first learned, they gave you apples or oranges or whatever, boys. Again, talking while I'm talking. I said, what is 3 plus 4? What you really didn't know then is you're effectively starting at 0, and you're adding 3, and then you are adding 4. And you can model addition on a number line, just like you can model subtraction on a number line. And we add 3, we increase our value by 3, and then when we add 4 more, we increase our value 4 more, and it gets us to the number 7. Okay? That's basically what addition is. Addition is taking one thing and adding to it, right? And up to this point, we've only added positive numbers. So when I take a positive number and I add another positive number, I am increasing its value. I'm increasing its value. Now, however, we get into the integer world. And the integer world has what kind of numbers? Negative numbers. Has negative numbers. So all of a sudden, what we know to be true is about to change a little bit. Because negative numbers are the opposites of the positive numbers. Negative numbers are the opposites of positive numbers. I'll give you a quick kind of scenario. If I have a positive number, a positive value, and I add to that the exact opposite value, what happens? It becomes 0. It becomes 0. This is what is called a zero pair. It is what is called a zero pair. It is a positive and a negative that when put together basically cancel one another out. Okay? Yes, ma'am?
Is that why on here, like in the middle of 0? Like
No, that's a whole different thing. Yes?
So if you had two different numbers and then still had a 0 pair, they have to be the same. They're positive and
That's a good question. So if you have two different values, you end up with a 0 pair. Yes and no would be the answer. And I'll show you what I mean. I'm going to show you the first way that we would model adding positive and negative numbers together. We're going to use our number line first. If I said I would like you to please model 4 plus negative 3. 4 plus negative 3. I just want you to watch and I'll let you put it in your notes. Number one, the very first place we always begin when we're doing any kind of a math problem, effectively you always start at 0. Everything starts at 0. And we're going to go from 0 to 4, which is our first number in our math sentence. So we go from 0 to 4. That is the 4 that we begin with. And then from 4, we're adding what? Negative 3. Which direction would that be?
Left.
To the left. 3. And effectively, this is adding negative 3 which gets us to our answer, which is 1.
So it is.
Yes, ma'am.
So when it says to add, you just basically like kind of subtract.
You kind of subtract, but I don't want you to think of it about subtraction. I want you to think about it as adding 3 negative numbers to your 4 positive numbers. You started with 4 positives, you're adding 3 negatives. Who was asking about? Brendan was asking about the whole 0 pair thing. If the red guys were our negative numbers and the yellow guys were our positive numbers, then when we have 4 plus negative 3, essentially we have 1, 2, 3, 4 positives we begin with, right? And then we're adding to that how many red circles? So every time we add a red circle, what are we creating?
A pair.
0 pair, 0 pair, 0 pair. What is left? Positive 1. Nolan?
It's sort of like subtracting.
It's a lot like subtracting. And tomorrow you're going to realize that really subtracting is a lot like addition.
Wait, so think about addition and subtraction and subtraction and addition.
Say again?
Subtraction.
We're going to get to subtraction tomorrow. I don't want to talk to subtraction today. I want to stick specifically with addition. Now, what's happening if you think about it, and then I'll get to your question. When you have some positives and you add to that some negatives, you have this 0 pair thing happening. Every one positive guy and every one negative guy get together and just go away because that's a 0 pair. They got no value. And it just keeps happening over and over again until you're out of either your positives or your negatives. Until you're out of either the positives or the negatives. If, for example, if I wanted to, let me put these guys back over here in the negative corral and these guys in the positive corral, if I wanted to model negative 8 plus 2, what would I start with? Bennett?
You would start with 0.
Yeah, and then I would do what?
You first go to 2.
Nope, that's not the math sentence. We read left to right. Gavin, what would we do first? If we're reading this math sentence, what is our first action, so to speak? Nolan?
You get 8 red dots.
We would get 8 red guys because we start with our negative 8. 1, 2, 3, 4, 5, 6, 7, 8. And so do I now have 8 negatives in this group? I do. To that, it's asking me to do what? Add to what? 2 positive numbers. When I add my 2 positive numbers, what is this? What is this? What is remaining? 6 negatives. 6 negatives. 6. So effectively, if we take any positive amount and we're adding to that a negative amount, we are really finding what's the difference between the two. We're really finding the difference between the two because there are cancellations happening. Andrew?
Can I go to the bathroom where you're at this?
Yeah, go ahead. Labib?
So you would do like a wrong, like positive 4 plus
Well, yeah, because we can use this this exact process, guys, even if we're just adding regular numbers. If I had 4 plus 3, remember that was our very first thing. If I had 4 plus 3, what would I start with? 4 positive guys, and then I would add to that
3 positive.
3 more positive guys, which would end up as 7 positive guys. Gavin?
So if there's negative numbers in the equation, you always start with the negative?
Yeah, if that's your first number. Yeah. What if I have this? Negative 3 plus negative 5. Sarah, what would that be, do you think? It would be, because I'm starting with 3 negatives, and to that I'm adding 5 negatives, and once I get them all together,
There's 8.
I have 8 negatives.
So, look at this. What about, no cancellations. What about negative, like either decimals or something? Like if they're repeating or something?
Well, let's stick with integers today.
Yes, sir, but I do have a question. For this, if there was a negative decimal.
Let's stick with integers today.
Okay, so what about, is integers still fractions? Negative fractions?
Integers, never. Integers are the collection of positive whole numbers and their opposites. There are no fractions and there are no decimals.
So what happens if it was,
If you say decimal, I'm going to throw something at you.
if it was not a decimal and if.
No, really, we need to stick with integers today.
No, I know. I know.
If there's a
Well,
fraction.
I wasn't even gonna say that, but what happens if there's like a bigger number on one side than the other, and you have to like add two aside?
Let's try this.
Like,
I'm going to tell you kind of how, by the way, the zero pair thing works. Because the cool thing is you can draw zero pairs on your, remember I had the circle with a plus and the circle with a minus? You can draw zero pairs yourself, if that helps you. But here's what I want you to watch really quickly, then I'm going to ask you a question, see if you can answer it. What if the numbers get crazy bigger?
It doesn't make a difference.
you're gonna take a long time.
It does make a difference, actually,
Well, I'm saying.
because it's a difference.
Yeah.
Booyah!
Oh, that's.
Walk right into that one.
So I thought that you were kind of different.
Okay. So, here's my question. I want everyone just to listen for a second so everyone kind of has a chance for their brains to chew on this. Hold. Just wait. I want everyone's brain to chew on this. If I have, what's the 54? Positive or negative? It is positive. And to that I'm going to add 32 negatives. What I want you to imagine in your head is if you have a pile of 54 positive numbers, and to that you're going to add a pile of 32 negative numbers. And what's basically happening, although you can't really see it, is that each positive and each negative are getting together and basically disappearing because they're creating a zero pair. Is my answer going to be positive or negative at the end? And why? I need you to start raising your hands. And why, Jaden? No, is it going to be positive or negative? Answer that first. It's going to be positive. Why do you say that? Yeah. So ultimately, how would we find out how many positive guys are left over after all that zero pairing happens, Claire?
You do 54 minus 32.
You basically do 54 minus 32, which gives you this as an answer. Now, I will tell you that that's the way I add positives and negatives. If I add positives and negatives, I don't really break out zero pairs, although you need to know what it looks like because they may test you on that. I don't really take out a big old ginormous number line where I go all the way to positive 54, and then I go backwards 32 places so I can end up at 22. What I do is I imagine all those zero pair things happening until I figure it out. Ben, do you have a question?
Why do you put a plus to the left of 22?
It's a positive number.
Because it's a positive.
Yeah.
Because the first thing I asked was, is it positive or negative? When he said positive, I put that there just to kind of re-emphasize it.
Just to make sure.
But the point is, I think Bennett's point is, you don't have, if you don't see a value written, we assume it is positive. So you don't necessarily have to have it written. It doesn't make it wrong, though. Okay?
Wait, that didn't make it wrong? If you add the positive?
No.
But then it.
I'm getting graded.
Oh, yeah.
Yeah.
Mine plus 22.
Okay? Does everyone get that? What if, how would it have changed if I wrote that? Now, don't answer out loud. Think about it for a moment. And tell me and describe, Cameron, how that would have changed my answer.
Instead of doing subtraction with them, you would add them.
You would basically add them because, Gavin, do you have a question, a statement?
Huh?
Tell me.
I know the answer, but
Go. Bust it.
Okay, 86. The answer is minus 86.
It is negative 86, not just 86. That would be wrong. Because basically I have a pile of 54 red circles here, and then I have 32 red circles here, and when I put them all together, I end up with 86 red circles, which represents negative 86.
So I'm right?
You're right.
Yay. You're right.
If I had negative 14, here's one. Think of this. What if I had negative 14? What would I have to add, and do not yell it out, to negative 14? Think it through in your head. Don't say it out loud. Jackson?
You have to add 30.
I would have to add 30. I would have to add 30 because I have to go, if you think about that number line, I have to go from negative 14 past 0 all the way to positive 16. If I'm going to the right from negative 14, just to get to 0, I have to add how many? 14. Then I have to add 16 more to get all the way to where I need to go.
So would you have to subtract that?
Nope, we haven't even talked about subtraction.
No, I'm talking about skip the answer.
No.
Why couldn't we add? That's what we're missing.
What?
Mr.
Does this not make sense to anyone real quick? Brendan, go ahead, and then Jackson will get to you.
So I'm confused on when you're supposed to, because earlier you said that we have to subtract to get some of the answers.
No, I didn't. I said you have to find the difference.
Yeah.
And here, but here's the thing, watch, Brendan, it's a different thing. If I have negative 14, that's where I'm starting in my number sentence, right? And I'm ending at positive 16, because that's what I had written on my number sentence. How do you get from here to here? That's basically the, you would, no. Think of it like you're walking a distance. If you're standing at negative 14 and you have to get to positive 16, how many steps must you take?
Depends.
No, it doesn't at all.
Depends on how long your stride is.
It doesn't mathematically at all.
It's called real life.
Okay? Brendan, how many steps do I need to take to get from negative 14 to positive 16?
So will you add 14 to get to 0?
Yep.
So would you take that 14 that you already added and add it to 16?
How many steps will you have totally taken?
So if you add 15, that's 30.
Yeah. Now, again, seriously, it's a difficult concept to get, so you can imagine how subtraction really becomes a whole different deal. But with regard to addition, you're simply putting two piles of things together. And one of two things is going to happen. You're going to take a pile of positives and add it to another pile of positives and get a bigger positive number. You're going to take a pile of negative guys and add to that another pile of negative guys and get a much smaller negative number that's further away from 0. Or you're going to take a negative and add to that an opposite number, a positive. In which case, they begin canceling one another out, and you have to figure out how many are left over at the end. Brendan, that's the point I was trying to make. Jackson?
Well, theoretically, couldn't you just add the sum and then and then couldn't you just add 14 and 16?
You could, but that's not 14, it's negative 14.
Yeah, negative, but couldn't you take away the negative? Don't take away the
Well,
negative.
you
No,
shouldn't.
take away the negative.
I know what you're saying, though.
Yeah.
Which brings me to my next point. Carol, I'll let you talk, and then we'll talk about one other thing, then we'll get into classwork so we can get classwork and homework done.
The second number is bigger than the first one.
Let's see. Negative 8, like negative 8 plus 12?
Like negative, yeah.
Okay.
I understand.
I have a pile of negative 8.
Oh, 4.
I'm adding to that positive 12. The 0 pair of things are happening.
Positive 4.
Positive 4.
Wait, but I don't understand why I'm
Okay, let's do one other thing and then we're going to do some whiteboard practice. Andrew.
When you wrote down negative 8 plus 12 equals 4, pretty much all you have to do is switch it to subtraction, but take the negative number and
Basically what you have to do.
yeah, like switch them.
One other quick thing. Who can describe for me what this term means? Sierra, take a shot. Absolute value means, gentlemen, absolute value basically means how far something is from 0. I want you to look at the number line under Bob Marley over to this side of the room. And I want you to look at the number 7. How far is the number 7 away from 0? 7. So what we would say, I want you to make sure you know what it looks like. It's basically 2 lines on either side of the number. So the absolute value of 7 is 7, because that's its distance from 0. How far is negative 8 from 0? It is basically 8 steps. So the absolute value of negative 8 is 8.
Wait, but I don't understand why would you do that?
I'll show you why. Watch, just listen. If I'm standing at this, and I want to measure the distance from me to that wall, I would simply take a tape measure and measure, correct? Does that make the distance from me to that wall a negative number? No, it absolutely does not. There's no such thing as a negative 8 feet.
Wait, so if you went, why would you do that? Because obviously if it's 8 feet and the distance away from the person is 8.
Thank you, Jackson, which is my point.
Oh,
That no matter whether you're measuring to a positive number or a negative number, the distance to that number is positive. If I want to measure to that wall, I would simply turn around and measure to that wall.
yeah, the entire absolute value thing is kind of stupid because really, why don't you just know in your head that 7 is 7 away from 0?
Because when you get into Algebra 2 and you begin evaluating the absolute value function, you won't consider it to be stupid, you'll consider it to be somewhat confusing. Because y equals 3x plus 2 is a function, y equals the absolute value of 3x plus 2 is a very different function. So what I need you to understand is basically absolute value simply turns any number into a positive number. It turns...
The absolute value of 3x plus 2 is 3x plus 2.
No, it's not. You don't need to. I was just making a point as to why you don't really quite know everything yet and why you need to understand absolute value at the level that we're testing.
Wait, we have to know it at the level we're testing?
You have to know that absolute value at our level simply turns any number into a positive.
That's it?
Yeah.
That's pretty simple.
Okay? Oh, I've heard that before, and sometimes our work has not necessarily shown that, Jackson. So, you don't have a 100 average, though.
I have an A average.
You don't have a 100 average.
But, yeah.
Yeah. Good comeback, sir. Okay. Get your dry erase boards and your markers, please. Now, let me explain my dry erase board rules. Everyone listen up. I'm about to chuck that in the garbage.
Why can't you just chuck it?
I know, keep cell phone.
You want my dad's cell phone
I
number?
do. All right, so here are my rules. Everyone listen up. Here are the rules on dry erase board. I want you discussing it with someone else. I will give you a problem. You will write down the problem, give me an answer. You will box the answer before you show it to me. At that point, you'll simply show it to me. If I give you a thumbs up or a yes, you may then erase it and wait for the next problem. Okay? What I need to be able to do is check, and I'm trying to kind of check and make sure everyone's in an I kind of get it place. Okay? So make sure you keep that in mind as we go. Okay? Brendan, stop speaking while I'm speaking. This is happening a lot. Thank you. Okay? So here we go. Let's start off with something fairly straightforward. Now remember, we're either piling up negative guys and getting more negative guys, we're piling up positive guys and getting more positive guys, or we're adding positive and negative guys, in which case they're canceling one another out. So let's start with that. Nope. Nope. You have to do exactly what I said to do, and you were talking while I was talking, so why don't you try to figure it out? Thank you, you're good? No. Yes. No. Yes, Claire, you're good? Yes, thank you. Because you didn't listen either, Bennett.
Darn it, I can't listen.
No, Christopher. Yes, yes, yes.
Now I have it. Now I have
Here, I
it.
tried to
Thank you, Bennett. Yes, Jason. No, Gavin. Yes, Andrew. Yes. Yes, Jackson. Thank you.
What?
Yes.
They have the same answer.
Yes.
Yeah, but.
Yeah, except you wrote the problem. What I said to do, and you did not. Thank you.
Oh, I see.
Thank you, thank you. Okay, so everyone listen. No kidding.
Stop. You give me one, baby.
I want everyone to listen to me, please. Thank you. Bennett Powell, this is why you don't get it the first time. You're not listening. Jackson, you didn't either.
Okay, but I fixed it.
I'm glad, but I'm tired of having to repeat myself.
Okay, yes, sir.
I need you listening the first time. Bennett, Michael, I'm done. And it's being recorded. All I have to do is reference the minute we are at and ask your mom to listen to it. Thank you. I desperately need you to start listening the first time. Okay? I need you to start listening the first time. I want you to rewrite the problem. Then I want you to give me an answer and box it. Box it, please. I'm ready for your next shot. That's why recording classes are going to be kind of fun.
Can you circle it?
Huh?
Can you circle it?
Did I say circle it?
You said box it.
Right.
I was just thinking, because you always say box it, but then you say it, you include circle it.
Ready, set. Remember, start making an evaluation. My answer is going to be a negative, it's going to be a positive, and how exactly I'm going to get there. You know that? Yes, sir. Thank you. Think about it. Thank you, Bennett. You're good. Thank you. Good. Very good. Thank you. Thank you. Thank you. Good. You're good, Bennett. Thank you. Good job. Now remember, good. Good, Bennett. Make sure you're boxing your answers right. Thank you. Make sure you're making that determination as to whether or not your answer is going to be a positive or a negative, exactly how you arrive at that number. Good. Thank you, Jackson. Thank you. Good, good. Do my waiting on. Thank you. Make sure you're boxing your answers. Thank you. Boxing. Alrighty. So if I have a pile of 38 positives, listen to this, and I'm adding to that a pile of negatives, which pile is larger? The negative. So I know right off the bat my answer is going to be negative. Now I also know that these zero pair things are happening. So for every positive, there's a negative that's going to cancel it all out. Which one will I run out of first? The pile of positives or the pile of negatives, Brendan? I'm going to run out of the positives first. So to figure out the difference between the two, essentially, I'm doing this. So my answer is negative 15. Now, to see this on a number line, I want you to watch, because we didn't talk about a number line a lot. Essentially, this is what happens. On a number line, you would start at 0. You would go to 38 positive, which is right here. And from there, I'm going to go this way 53 places. Now, if I'm going this way 53, how much is taken up here to here? 38. So what's left ends up at negative 15. That's the way it works on a number line. In fact, wherever the last arrow points, that's essentially your sum. That's essentially your sum. Let's try 2 more, and then we'll get into classwork homework. Clear your boards. Negative 22 plus negative 79 plus 80. think it through. There are actually a couple of different ways to solve this one. A couple of different ways to solve this one. Yes, yes, yes. No. Cameron, no. No, you're good, Jason. Yes. Make sure you're boxing your answer, please. Yes. Labib, no. Bennett, yes. Yes. Yes, yes. Jaden, no. Yes, yeah, be good. Yes, Blair. Yes. Yes. Good. Very good. No, no. Can we give you about 10 more seconds, then we're going to go through it? Yes, thank you. What did you do wrong, Cam, on the first one?
I thought the 22 was
No.
positive. I thought 22 was positive.
I got you. Yes, and Andrew, no. So watch. What happens when I do this? I have a pile of negatives and another pile of negatives. So basically I bring them all together for a larger pile of negatives, which gives me negative 101 pieces. I add those negatives together. And then I'm adding a positive number. The zero pair thing is happening, and my result is negative 21. Now, some of you might have noticed in our original problem, if I'm adding negative 79 and then positive 80, essentially what am I doing? I'm simply adding positive 1. If you'd have added just a positive 1 to that, it would have simply become negative 21.
You do 101
Yeah. Okay, one more. Here we go. This will be your final one. Whenever I give you a yes and you're clear, if you will please bring your board up, stack it, put your dry erase marker in the box, throw away any tissues, and then I'll get your classwork passed out in just a moment. Here we go. Negative 13 plus what would get me 72? Negative 13 plus what? You're good? Good. Good. Yes? Where's your answer though? Yes. No. No. Yes, Jonah. No. It is not. Look at the board again. Read the board. You just read right. Yes. No.
Yes.
Yes. Yes. Yes. Yes, on to it. Let me see, Brendan. Oh, yours is still not right.
Wait, but
Yes.
you
Yes.
Oh,
Yes, will be.
good.
Good.
Oh, 80.
Good, Carol. Good. No.
Oh, I subtracted it.
Yes. Now you can see where it's very easy. Let me see again. Let me see. Yes and yes. Yes, you're good. I could see the 8 was a little bit skinny. Yes. Good, Dakota. Now again, if you're thinking about this from a number line standpoint, guys, almost done. You're starting at negative 13. Everyone, you're starting at negative 13. You first have to get to 0, and then you have to get to 72. To go from negative 13 to 0, that's 13. To go from 0 to 72, that's another 72. So essentially, you're adding 85. I need you to find a way that works in your brain. Boys, I'm supposed to clear your boards and put them up. Okay? All right. So let's get to classwork.